All right, so in this video, we are going to finish up 3.4 by finding the domain of a log function and also inverses of logs and exponentials. Okay, so finding the domain of a log function is kind of a review because I went over that with you in graphing log functions, right? And so all you need to do, right, is take your argument and set it not greater than or equal to 0, but just greater than 0, and then solve for x, and then you are done. So in interval notation, this is minus infinity to 3. Okay, so that's it. Set the argument greater than 0. So for this one right here, right, this is my argument. I set the argument greater than 0. And now you have a quadratic inequality, right? So if you remember how to solve this, you need to briefly change it to equal 0, get the x-intercepts. You're going to get -4 and +4, and then you have to test on the number line. Okay, so again, this is how you solve a quadratic inequality. You test, maybe we'll call this f. If you plug in -5 over here, right, you're going to get 16 minus 25, which is a negative value. If you plug in 0, 16 minus 0, that's positive. And if you plug in 5, of course, 16 minus 25, you're going to get negative. Okay, so I want all x values such that f is positive. So in this region, so your final answer is -4 to 4. Okay, so that's all there is to finding the domain of a log function. Again, why does it have to be positive? Because you can't raise a positive base to a particular power such that you get a negative number inside the argument or 0 inside the argument. Okay, so logs, again, are just exponentials, and that's why the domain of a log function has to be positive or greater than 0. Okay, so let's take a look at finding the inverse. Let's just do 2 examples. Find the inverse. Okay, so there's a couple of homework questions in the worksheet that ask you to find the inverse. So let's take a look at this first one right here. You have f of x is equal to log base 6 of x plus 2 minus 1. All right, so remember, to find the inverse, right, you need to switch the x and y. So currently this is my y, right? So I'm going to call this guy x is equal to log base 6 of y plus 2 minus 1. All right, so after I switch it, what I'm trying to do is to get y by itself. Now notice y is inside the argument. And so what you really want to do is to isolate the log. So I'm going to move this x plus 1 over right here. And now that the log has been isolated, right, isolate log, so you see what I did over here from this step to this step, treat this as a single term here on the left side, okay? And so to get y by itself, don't divide by the word log, okay? So a lot of students think log is a variable. It's not. You want to exponentiate both sides by base 6, okay? So exponentiate both sides by base 6. That's the only way to get something in the argument within a log by itself, okay? So now you have 6 to the x plus 1 is equal to y plus 2. Right, and of course you could just move that 2 over and now call it f inverse of x. And that's how you get the inverse, okay? So make sure you isolate the log. Use your inverse property, right? This is inverse property to get the variable which was inside the argument. Again, you cannot divide by log, okay? So I've seen students do that before. All right, let's just do one more example here, part B. Maybe we'll call it g of x is equal to 3e to the x plus 2 minus 4. Okay, so the first step, of course, is to switch the variable. So x becomes y, or y becomes x. And over here, my x becomes y. Right, well, just like the previous example, right, I needed to isolate the log. Over here, I need to isolate the exponential. Okay, so in other words, get your e right here by itself. So first things first, right, add 4. And of course, you divide by 3. And I have gotten my exponential by itself. All right, now, key step right here is to treat the left side as a single term. In other words, put that in parentheses. And to get y by itself, right, instead of exponentiating like the previous problem, right, this is already exponential form, what you want to do is take the ln of both sides, right? Take the ln of both sides because I want to get y by itself. Whatever you do to the right, you do to the left. And ask yourself, why am I taking the ln of both sides? Because I want to bring this y plus 2 down, right? If I bring it down, this ln of e right here, right, just becomes 1. Right? This evaluates just to 1. Okay, so that was the key line right here from this line to this line is by taking the natural log of both sides. Y plus 2 times 1, of course, is just 1. Sorry, y plus 2. Finish up this problem, right? You have x plus 4 over 3 and I subtracted by 2, and I'm going to call this g inverse of x. Okay, so that's how you find the inverse, right? You switch the y and the x. You want to isolate either your exponential or your log, and you use your inverse property. Okay, so whether you take the log of both sides, if it's an exponential form, or you exponentiate by both sides, such as on this line by base 6, if it's in log form. And pretty much the process is the same as finding an inverse the way I taught you in chapter 1, right? Switch to y and x and get y by itself. Just be careful, do not